Lesson: AI-driven software design patterns. AI-driven software design patterns represent a significant advancement in software development, offering new paradigms for creating intelligent and adaptive systems. By integrating AI into the architecture and design patterns traditionally used in software engineering, developers can significantly enhance the functionality and efficiency of software solutions. This lesson focuses on actionable insights, practical tools, frameworks, and step-by-step applications that professionals can leverage to address real-world challenges and improve their expertise in AI-driven software design. The concept of design patterns in software development serves as a blueprint for solving common problems in software design. These patterns provide reusable solutions that can be adapted to various contexts, facilitating efficient software construction. With the emergence of AI technologies, these patterns have evolved to incorporate machine learning algorithms, data processing techniques, and intelligent automation processes. AI-driven design patterns thus offer solutions that are not only efficient and scalable, but also capable of learning and adapting to changing inputs and environments. One of the most impactful AI-driven software design patterns is the use of decision trees for predictive analytics. Decision trees are a supervised learning technique that can be used to make predictions based on historical data. They work by splitting the data into branches based on the value of different attributes, eventually leading to a prediction. This pattern is particularly useful in applications such as customer segmentation, fraud detection, and risk assessment. For instance, in the financial industry, decision trees can help in identifying potential defaults by analyzing historical customer data and identifying patterns that precede defaults. Another critical design pattern is the use of neural networks for complex pattern recognition tasks. Neural networks, inspired by the structure of the human brain, consist of layers of interconnected nodes that process data inputs and produce outputs. They are particularly useful in applications that require high-dimensional data processing, such as image and speech recognition. A practical application of this pattern is in autonomous vehicles, where neural networks are used to process visual data from cameras to identify obstacles and navigate roads safely. Tools such as TensorFlow and PyTorch provide frameworks for developing and deploying neural network models, enabling developers to implement this pattern efficiently. Reinforcement learning represents another powerful AI-driven design pattern, where an agent learns to make decisions by interacting with its environment and receiving feedback in the form of rewards or penalties. This pattern is particularly effective in scenarios where the optimal solution is not immediately apparent and must be discovered through exploration. For instance, Google's DeepMind used reinforcement learning to develop AlphaGo, a program that defeated a world champion Go player by learning optimal strategies through self-play. Implementing reinforcement learning can be complex, but tools like OpenAI Gym and Stable Baselines provide structured environments and pre-built algorithms to facilitate development. The integration of AI into software design patterns also involves addressing challenges related to data processing and management. Data pipelines, for example, are an essential component in AI-driven applications, ensuring that data is collected, processed, and analyzed efficiently. A design pattern that addresses this need is the Lambda architecture, which combines batch and real-time processing to provide comprehensive data analytics. The Lambda architecture is particularly useful in systems where timely insights are critical, such as real-time recommendation systems or fraud detection in financial transactions. Apache Kafka and Apache Spark are tools that can be used to implement Lambda architecture, providing robust platforms for streaming data ingestion and processing. AI-driven software design patterns also necessitate a focus on model deployment and scalability. The microservices architecture is a design pattern that facilitates the deployment of AI models by breaking down applications into smaller, independent services that can be developed, deployed, and scaled independently. This pattern is particularly beneficial in environments where different AI models or components need to be updated or scaled without affecting the entire application. In practice, companies like Netflix have successfully implemented microservices to deploy AI-driven recommendation algorithms that personalize user experiences. Tools such as Docker and Kubernetes offer essential capabilities for managing and orchestrating microservices, ensuring efficient deployment and scaling of AI models. To effectively implement AI-driven software design patterns, professionals must also consider ethical and security implications. AI systems can introduce biases based on the data they are trained on, leading to unfair or discriminatory outcomes. Therefore, incorporating fairness and transparency mechanisms into AI design patterns is crucial. For example, IBM's AI Fairness 360 Toolkit provides a comprehensive suite of metrics and algorithms to detect and mitigate bias in AI models, ensuring that AI-driven solutions are fair and ethical. In addition to ethical considerations, security is a critical concern in AI-driven software design. AI models can be susceptible to adversarial attacks, where malicious inputs are crafted to deceive the model and produce incorrect outputs. To address this challenge, design patterns that incorporate adversarial training and robust model evaluation are essential. By training models with adversarial examples, developers can enhance their resilience to such attacks and improve overall security. The Clever Hands library is a practical tool that provides implementations of adversarial attacks and defenses, enabling developers to test and strengthen their models against potential vulnerabilities. AI-driven software design patterns offer transformative potential for software development, enabling the creation of intelligent, adaptive, and efficient systems. By leveraging practical tools and frameworks, professionals can effectively implement these patterns to address real-world challenges and enhance their proficiency in AI-driven software design. Whether through decision trees, neural networks, reinforcement learning, data pipelines, or microservices, the integration of AI into software design offers new opportunities for innovation and problem-solving. As AI technologies continue to evolve, staying informed about the latest patterns and tools is essential for professionals aspiring to excel in AI-driven software development.